right? And it is thermometers, right? Let me start my video. Okay. Yes. Yeah. Page, chapter number 20, page 85 of your book. Okay. Before I start this chapter, I want to know how many of you know the definition of temperature. Definition of temperature. Exact definition of temperature. Who is? I am following your hands. If I see raised hands, then I'll unmute that person. Or you can just write down in the chat window. Who knows the definition of temperature? Hafsa Khalid, can you please mute yourself? I'm trying to mute you, but I can't. I don't know why. And Usman Aslam, you as well. Okay. Okay, Nu Afridi. Okay, you know. Okay, I'm unmuting you. Please tell me the definition of temperature. Yes? Yes? Nu Afridi? Can you hear me? Okay. Okay, Ibrahim. Okay, Ibrahim. Yes, Ibrahim?
It's the thing to measure some things warm. If it is warm or cold.
Is that the definition? No, 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 no. Nu Afridi? Okay, Yusra. Yes, Yusra?
Temperature is like the physical property of matter that will tell us whether the matter is, it will express whether the matter is hot or cold.
Okay, I'm going through all these definitions that you guys are writing in the chat window. And yes, devil. By the way, please rename yourself. Please use your real name, for God's sake, or at least a human's name. Okay, temperature is for something how hot or how cold it is, and also average kinetic energy in the object. Yes, this latter part, average kinetic energy of the object. This is the definition of temperature. Remember, temperature is the average kinetic energy of the molecules in an object. Okay, remember that. Yes, how hot or how cold was the definition for as long as you were in grade 1, 2. Till grade 1 and 2, that's the definition of temperature, of how hot or cold an object is. That's the definition till that level, grade 2. After that, it is the average kinetic energy of molecules of an object. Okay? Remember this, average kinetic energy. Now, what do I mean by that? What do I mean by average kinetic energy of molecules of an object? Okay, today I'm going to talk in detail about this. Okay, I have made this, you know, all these terms that we have: thermal energy, heat, temperature, right? Today, we are going to talk about how these terms are different from each other. Okay, how are these terms different from each other? I made this for you guys. I hope you can see it. Okay. First of all, what is a total? First of all, what is a total internal energy? Total internal energy is the same as thermal energy. Total internal energy is the same as thermal energy. I can call both. So whenever you come across the term thermal energy, it is the same as total internal energy. What is it? Total internal energy. Now I made this object. Okay, these are 6 molecules. I made only 6 big so that it's easier for you to understand, to keep things simple so that you understand. Now each molecule, can you please bring it a little closer? Okay. each molecule has kinetic energy and potential energy. EK, I'm using the symbols EK, E for energy, K for kinetic, E for energy, P for potential. The total energy of a molecule, the total energy of a molecule is the sum of its kinetic and potential energy. It is the sum of its kinetic and potential energy. So I have just given these random numbers, okay? And these, by the way, are joules, because remember the unit for energy is joules. Okay, so this is joules. These are all joules, but I did not write J because I did not have a space. Okay, but you understand. So kinetic energy here is 1, potential 2, 1, 1, and these are some random numbers I gave them. Okay, now if I want to calculate the total internal energy of this object, okay, and assuming it is composed of only these 6 molecules, then I will calculate the sum. I will calculate the sum of kinetic energy of all the molecules and the sum of potential energy of all the molecules, meaning I will add all of them. I will add all of them. So the total energy of this molecule is 2 plus 2, 4. Total energy of this molecule is 2 plus 3, 3, 2, 4, 4, 6. I added them together, I got 23 joules, okay? So 23 joules is the total internal energy or the thermal energy of this object, okay? So don't be confused. Thermal energy and total internal energy are same thing. They are the same thing, but temperature is not. Temperature is a little different. Temperature, as I just told you, is the average kinetic energy, right? So I took kinetic energy of each molecule. Can you see? 2, 1, 1, 2. I'm not adding potential energy. This is only kinetic energy. I am not considering potential energy in this case. When I want to know how much temperature. Temperature will only represent average kinetic energy, will not take into account the potential energy. Remember this, okay? So I have added all the kinetic energies of all the molecules, 2 plus 1 plus 1 plus 2 plus 3 plus 4. I got 13 joules. And I divided that by the total number of molecules, which in my example are 6. There are 6. So I divided that by 6. So the sum of kinetic energy divided by the total number of molecules will give me an average of, you know how to calculate averages, right? In mathematics, you know how to calculate the averages. So I have applied the same formula. You add all the kinetic energies, you divide by the number of molecules. That will be the average kinetic energy or temperature. Okay, now when we measure temperature, now by the way, this is joules and temperature is not in joules. Temperature is in different units, degree Celsius, Fahrenheit, Kelvin. But whatever scale you are using, the energy that it is representing is this. That is what you should know. It is representing this. Now this energy can be shown on a thermometer in any scale that you are using, degree Celsius, degree Fahrenheit, or Kelvin, okay? Now, so now you know temperature, you know total internal energy and thermal energy. And now we come to heat. Now what is heat? Remember, heat is not the same as thermal energy. Many people get confused. They treat heat to be synonymous with thermal energy. They take heat to be the same as thermal energy. No, scientifically, to be exact, they are slightly different from each other. Thermal energy, as I've already explained you, is the total internal energy, okay? Which in my case was 23 joules, right? Average kinetic energy represented by temperature is 2.16 joules, right? Now this is another object. And the thermal energy of this object is 10 joules and its average kinetic energy, for example, is 1 joule, okay? Now you can see that the average kinetic energy here is lower. Total thermal energy here is lower. So the energy, the thermal energy will flow from the object which has more thermal energy or which has a higher temperature to an object which has a lower temperature or which has lower thermal energy. Because energy, just like everything else, moves from where it is more to a region where it is less until both of them come to the same temperature or they come at the same temperature, then the flow will stop. Now, the energy which flows is called heat. Heat is a term which is given to that thermal energy which is flowing, which is getting transferred from one object to another. That is heat. Okay, so if you are asked to define heat, you can say that heat is that part of the thermal energy which flows from an object which is at a higher temperature to an object which is at a lower temperature. Okay, so these terms should be clear in your mind. Okay, you should know thermal energy, you should know total internal energy, and you should know heat. Okay, joules is the unit for energy. Hala, joule is the unit for energy, and this is only for your understanding. Okay, I'm not doing energy, all the types of different energies here, only these terms, because these will come in handy while we are studying thermometers. What is the difference between heat and energy? I just explained you. Okay, I just explained you. If you guys are not clear on this, you can listen to my recording. Listen to my recording, listen to this again. Okay, from the beginning if this is not clear. Heat is that part of the thermal energy which is transferred, which is flowing. Flowing thermal energy is called heat, which is flowing from an object which is at a higher temperature to an object which is at a lower temperature. That is heat. Okay, I hope it is clear. And if it is not clear, you can listen to my recording again. Okay. Energy is the ability to do work. Energy is the ability to do work, whereas heat is a form of energy, flowing thermal energy. Okay. Okay. Where do you send the recordings? I send the recordings in the group that I have made. Okay. Okay. Liquid in glass thermometer. Okay, now let's just start with the thermometers. Once you have understood these. Okay, another point before I start with the thermometers is that here, total internal energy. Now, total internal energy was what? It was a sum of kinetic energy and potential energy. Okay, don't forget the potential energy. Now, sometimes only the potential energy of molecules increases and kinetic energy does not. So the total internal energy increases, or the thermal energy increases, because the sum will increase, right? If you are increasing only potential energy, the total internal energy of the molecules will increase. But the kinetic energy will stay same, and therefore the average kinetic energy will stay the same, and therefore temperature will stay the same. And remember, thermometers are instruments which can detect change in temperature. They cannot detect changes in the thermal energy. They cannot detect the changes in total internal energy. They can only detect changes in average kinetic energy, which is temperature. You understand that? That is why I don't want to confuse you, but if you remember in your grade 6 and 7, when something is boiling or changing its state, the temperature stays constant. Remember, during boiling, the temperature stays constant until and unless all the liquid molecules have turned into gas. Remember? Now, why was the temperature constant while you were still providing heat? Because the potential energy of the molecules was increasing, but the kinetic energy was not increasing. And therefore, the thermometer was not able to detect any change. The temperature was constant. Okay. So this is what I have mentioned here, that the total internal energy can also be increased by only increasing the potential energy of molecules. Thermometers can only detect changes in kinetic energy of molecules. They cannot detect changes in the potential energy of molecules. Okay, now having said that, now let's move on to the thermometers. Okay, any question regarding this concept? Okay, okay, let's move on. Okay, now, okay, now what are the qualities of a thermometer? Now, thermometer, of course, we want some criteria to be able to measure temperature. Now, how do we do that? We make use of some physical property of a material that we can easily observe and measure. Not only observe, but we should be able to easily measure some change in physical property that will accurately represent the change in temperature, and that change should be continuous and uniform. Okay, for example, expansion. Okay, expansion is increase in volume. Now, as the temperature increases, if that material's volume increases, then the volume of that substance can give us some idea regarding the temperature. So we can use the volume of that material as our measure of the temperature, right? But this is one example. This is one example. We can use other physical properties to represent changes in temperature, such as pressure of a gas, or such as the color of a liquid, or we can we'll come across more examples. Okay, so whatever the physical property you are using, the changes in that physical property should be easily measurable and should accurately represent the changes in temperature. Okay, and also, of course, we want instruments which are small enough for us to handle, okay, which are accurate and which are not harmful, which are harmless. So we will keep all these factors in mind. So let's talk about the liquid in glass thermometers. Okay, now liquid in glass thermometer, as the name suggests, there is some liquid within the glass. Okay, now that liquid, of course, should be easily seen. That liquid should be easily observable. Okay, it should expand and contract rapidly. Rapidly meaning as soon as there is change in temperature, there should be change, there should be corresponding change in its volume. If the response time is delayed, that will decrease the sensitivity of the thermometer, meaning that the temperature increased a few seconds ago, and this liquid expanded a few seconds later. So maybe now after a few seconds the temperature is not the same. So our readings will not be true representatives of the changes in temperature. So this is called sensitivity. Okay, so higher the sensitivity, rapid the changes in the volume. Okay, then it should expand or contract by a large amount. I mean, it should be considerable for us to be able to measure. Now, if it is expanding by only 0.00001 something millimeter, then it is not possible for us to measure it. It would be difficult. Okay, so expansion or contraction should be measurable. It should be large enough for us to be able to measure it. Okay, then should not stick to the walls of the tube. The liquid should not stick to the walls of the tube. Now, of course, if the liquid will stick to the walls of the tube, we will not be able to read the levels accurately, first of all. And then when the temperature falls, the liquid should be dropping, but it will get stuck to the walls of the liquid, and we would have higher reading, meaning we would think that the liquid is still there at that reading, while actually the liquid has fallen down. Keep this mercury in liquid thermometer in your mind while we are discussing. Okay, now there are two liquids which are commonly used as liquid in glass thermometers. One is mercury in glass thermometer, the other is alcohol in glass thermometer. Now, mercury we know is a molten metal, and it is shiny and therefore easily visible. So, but it has its own disadvantages. I have made this list of advantages and disadvantages. By the way, I think this is also written in your book. Okay, the advantages of mercury in glass thermometer is that it is cheap, durable. Durable meaning that it is like not delicate. It's not fragile or delicate. We can easily handle it. We can easily handle it. It is accurate, meaning the contraction and expansion is pretty rapid. Response time is quick. As soon as there is change in temperature, it expands or contracts pretty good. And then we have easy calibration. Now we will talk about calibration in a while, but let me discuss the disadvantages first. Now the freezing point of mercury is minus 39 degrees Celsius, meaning that below this temperature, it will turn into a solid. It won't be a liquid anymore. So if it turns into a solid, then it won't be able to move up and down as such. And in fact, it will crack the glass. So we won't be able to use it. So we cannot use mercury for temperatures below minus 39 degrees Celsius. So that's a disadvantage. Here they have written slow response and here accurate. How is that? Okay, leave this. Okay, and then mercury is poisonous. Okay, mercury is poisonous. And then I think I should cut these 2 points. Well, if you talk about the glass is fragile, but yes, it is to some extent durable as well. I mean, if you handle it decent enough, it will last, it will work. I mean, it has been working for so many years. Okay, then alcohol thermometer has its own advantages and disadvantages. Alcohol, as you know, Ag is symbol for mercury, Yusra. Okay, Ag is symbol for mercury. Okay, alcohol thermometer, alcohol in glass thermometer. Now, alcohol, we all know, is a volatile liquid. Volatile meaning it has a low boiling point, considerably low boiling point. It evaporates. If it evaporates, or its boiling point is 78 degrees Celsius. So 78 degrees Celsius is not very far from room temperature. You know, we get around 40, 45 in summers here. So yeah, alcohol can evaporate. So we cannot use alcohol as a liquid in glass thermometer for temperatures around this value, because then it'll turn into a gas. We won't be able to see it, right? And so we cannot see it expanding or contracting. We cannot see its level against the scale. So that is our limitation. But its freezing point is minus 114 degrees Celsius. So that means alcohol is preferred when we are measuring low temperatures, okay? And mercury is preferred when we are measuring higher temperatures. I don't know, I forgot to write the boiling point of mercury. It's pretty high. So for higher temperatures, mercury in glass, and for lower temperatures, it's alcohol. Okay, now let's move on. Okay, let me, before I go into the calibration, let me take questions from you. If there are any questions, let me check the chat window. Okay, 20.1. What is 20.1? Use of a thermocouple probe thermometer to measure a temperature of about, yeah, they're just showing the thermometer, which is thermocouple, that we are going to discuss ahead. And it has a very high, it has a very wide range of temperature that are measurable, and therefore lava, which has temperatures above 1000, can be measured by thermocouple. By the way, I haven't discussed thermocouple as yet. Polymerize, I just wrote it down there. Polymerize meaning many molecules covalently bonding with each other. Okay, polymerize means many molecules. You have done polymerization in grade 6 chemistry. Polymerization is when many molecules make covalent bonds with each other and form long chains. Okay, Haya, don't you worry, I am recording this, you can get it. Okay, yeah, the advantage and the reason why I'm recording my lectures is so that I don't have to repeat, and you guys can always replay it and, you know, listen to it for as many times as you want. Okay, and you can also, and in the recording you also see what I'm showing in the videos or when I share my screen, so you guys can get my pictures and, you know, whatever tables I'm showing you. Okay, and if you don't have time for listening to the recordings, I can even share these pictures in the group. Okay, but because, you know, I'm here only for 1 hour, I'm trying to cover as much as possible for as long as I'm not too fast for you guys. Okay, I don't want to be too fast on you guys, and I don't want to be bombarding you with a lot of information together. If you feel that way, then you let me know. I will slow down. Okay, I will slow down. No, I have not talked about pascals here. Alcohol thermometer used mostly in cold regions due to low. Yes, alcohol is used for lower temperatures. Yes, you are right. We can condense the alcohol, Ibrahim, but you know, while we are using thermometer as an instrument to measure temperature, we don't want to be evaporating and condensing within the thermometer. Okay, we don't want to do that. And our readings, because basically the purpose of thermometer is to give us the exact representation of the temperature. So if it will condense or evaporate, then the purpose will fail. It won't fulfill its purpose. Are you getting me? No need to hire, no need to copy. Okay, I will send in the group, don't you worry. Okay, okay, PA means pascals. Not here. I have not talked about pascals here. I have not talked about pascals here. Okay, now let me move on. I don't know where you saw PA. Okay, scale of temperature. Now let's get on to the calibration of thermometer. How do we calibrate a thermometer? Here. Now, I have highlighted this bulb and this capillary tube with a black marker and, you know, drawn this glass with a pencil so that, you know, I want you to concentrate on this bulb. Okay, this bulb, which will be filled with mercury or whatever liquid there is. Okay, and I'm talking about mercury right now because your book has explained mercury. And this is degree Celsius. Okay, this calibration is of degree Celsius. Now, what is the difference between degree Celsius, Fahrenheit, and Kelvin is in their calibration. The way they are calibrated, that's how they are different. Okay, now I'm just talking about Celsius for now. Now, for example, mercury was within this bulb. Okay, we inserted this bulb into ice when it was melting. Okay, so ice which is melting will be at what temperature? We know its temperature in degree Celsius. In Celsius scale is 0. So now before we even knew this, whatever the temperature where the ice is melting, I will insert this bulb into an ice which is melting, and I will see till where does the level of mercury go. Wherever the level of mercury reaches, I will mark that point with a marker or whatever, you know, with some marker, I will mark that point that, okay, the temperature at which the ice is melting is represented by this level. I can name it as the ice point. This is also given in your book. See, in your book, I'm talking about this figure 20.2. Okay, I'm explaining it. Okay, now I will very gradually raise the temperature of that ice. Okay, So that ice will melt, the whole of it will melt, and then I'll keep increasing the temperature, keep providing it with the thermal energy, and the level of the mercury will keep rising in response to the thermal energy, will keep rising. Sorry, kinetic energy. Yes, thermometers measure only kinetic energy. So yeah, I was wrong. To average kinetic energy. So so this mercury will increase, I mean, it will rise up the tube till it reaches a point. There I will see that the liquid has started turning into steam, has started evaporating, okay? I will mark that point where I start seeing the bubbles, where I first see the bubble. I will mark that point here. And remember, this is inserted into a container which was containing ice initially, and then I kept providing it with heat, okay, and now it's boiling. And I mark this point where I see the first bubble. Where I see the first bubble, I mark this point and I call this my steam point. Okay, I don't know what the temperature is. I'm just giving it a name, steam point, and I've given this point the ice point. So I know that when the mercury was here, the ice was melting, and when it reached here, it was turning into gas. So this is my ice point, this is my steam point. Now what I do is, I measure this distance between these 2 points, and I divide this by 100, okay? I divide this by 100, whatever it is. Let's suppose, okay, let me give you an easy number for understanding. For example, it was 100 centimeters, for example, just a random number. And I divide this by 100, okay? So I will get 1 centimeters, okay? So I will put 100 divisions with which will be, and each division will be 1 centimeter apart from each other, okay? 100 divisions like this, and I will go on, bring it closer. 100 divisions like this, okay, this way, and I will make sure that the distance between each division is only 1 centimeter, so that I can have 100 divisions here. Okay, this is how they calibrate the thermometer. This is the calibration of a thermometer in the Celsius scale. Now in Fahrenheit, they use some other fixed point. So these are called fixed points. This ice point and this steam point, these are called fixed points. Now you can use any physical property such as, you know, you can even take color. For example, some liquids change color according to the thermometer. So you will note down the color at ice point by keeping it, while exposing it to a melting ice. You will observe the color at the steam point where the water will start bubbling. That will be your steam point at that thermometer. And then, now different scales use different sorts of fixed points. Like Celsius used ice and steam. Celsius used ice and steam, which was very good practically for us. But I don't know, Fahrenheit has some other fixed point and Kelvin has some other, okay? But we are not discussing them. For now, we are not discussing them, only Celsius, okay? But they differ in their fixed points. What's the symbol for alcohol? Atika, alcohol is a family name of hydrocarbons. So it depends upon which alcohol you're talking about. For example, ethanol is an alcohol. And if you're talking about ethanol, ether means 2 carbons. This is chemistry. I'm not going into that, okay? Okay, Hala Shiraz, can you listen to my recording? Can you listen to my recording? Yeah, because if I will repeat, it will take time. Is it fine if I let you listen to my recording? Yes. Okay. Okay. Fixed points, you know, like in Celsius, like, you know, which points did you start? Which were your reference points? You take 2 reference points, you measure the distance between them and you divide them into your required number of divisions, which are different, you know, in these different scales. So I just to give you a rough idea of how they calibrate. But this method of calibration of Celsius scale is basically in, I think, in IGCSE. Okay. Okay. Now we come to clinical thermometer. Now, clinical thermometer is just another type of mercury in glass thermometer. They use mercury as the liquid, right? But the difference is that, let me show you. The difference is, I'm sharing my screen. The difference is that the range of temperatures that they use is a few degrees above and a few degrees below the normal body temperature, which is 37.5 degrees Celsius, if I'm not mistaken. So a few degrees above and below. So can you see, look at this picture. The thermometer is starting from 35 all the way till 40. Okay. So basically they have taken a few degrees above and a few degrees below the normal body temperature, because we are only concerned with this temperature range in clinics. So this is how clinical thermometer is different from mercury in glass thermometer. Okay. Now, another point that I need to emphasize here is the narrower the capillary tube. Now, what is a capillary tube? Capillary tube is this small tube within the glass that you can see. This is small tube that you can see within the glass, where inside which you can see the liquid, and which is in continuity with the bulb. Okay, bulb is where the liquid rests. And when this bulb should be exposed to the temperature you want to measure. This bulb should be exposed to that substance, the temperature of which you want to measure. Now, if the temperature is high, the liquid in this bulb will expand. And as it will expand, of course, it has no other way to go but to go up through this tube, which is called the capillary tube. Now, why is it called a capillary tube? Is because the liquid in this tube undergoes capillary action. Capillary action is when the forces of attraction between the liquid molecules and the walls of this tube are greater. Forces of attraction, I'm repeating myself. Capillary action takes place when the forces of attraction between the liquid molecules and the wall is greater than the forces of attraction in between the liquid molecules. Meaning the force of attraction between the molecules and the wall is greater than the intermolecular attraction. Intermolecular meaning in between the molecules of the liquid. Therefore, the molecules cling onto the walls of this capillary, and as a result of expansion due to heat, they are increasing in volume, they're expanding, and therefore they're rising and proceeding further along the tube. Okay. Now, when they're expanding in response to the heat, they will push their way through this constriction. This constriction is a bend, is a kink in the capillary tube. So they will push along this bend or kink, and they will move ahead into the tube. Now, what is the purpose of this constriction? The purpose of this constriction is to maintain the level of mercury even after the bulb has been removed from the body. Okay, because if we do not have this constriction, within 1 minute, the mercury will contract back due to the room temperature, which is lower than the body temperature usually. Okay, so the mercury will contract back before we can record it. So for the convenience of measurement, for the convenience of recording, they have made this constriction so that when the mercury contracts, only the mercury below this constriction will contract. Whereas the mercury, which has gone beyond this point of constriction, will stay where it is, and we can easily record it. Okay. Now there are digital thermometers these days, and because mercury is poisonous, and we used to keep this bulb of thermometer under our tongues, which is really, really dangerous, poisonous, you know, like one bite, even one accidental bite will break the glass and the poisonous substance in our mouth, which can be accidentally swallowed. So that would be an emergency. Therefore now, alhamdulillah, now we have come up with the digital thermometers. But this is how we used to have. Okay. So now another thing that I want to mention is that narrower this capillary tube, higher the sensitivity of the thermometer, because it is easier for the liquid to rise further, and therefore it responds to the changes in temperature quickly if the capillary is narrow. Okay, if the bore is narrow. Okay. Okay, now let me move on to any questions? Any questions? Let me see. Yes, narrow capillary is advantageous. Yes, narrow capillary is useful. Okay. Which liquid is used in digital thermometer? No, they don't use liquid. Their mechanism is completely different. Constriction is like a bend. It's a bend, you know, it's a kink. K-I-N-K, kink, constriction. It is, can you please refer to figure 20.3 on page 86. 20.3, page 86, and you can see what I'm talking about. Okay, figure to 20.3. This is the constriction, this bend. Can you see this bend? And can you see the range is only from 35 to 42? Okay, only a few degrees below and a few degrees above the normal body temperature. Okay, now we come to thermocouple. Yeah, thermocouple. Now here you have to know a little of electrical physics. Now as this, I will use this picture in your book. Now they have used these two different wires made up of two different metals. One is iron, the other is copper. Now copper, I remember I told you copper has one of the best conductivities of all the metals, followed by silver. So copper conducts way better than iron. Okay, now if they have two junctions due to hot liquid inside them. Okay, I will address that question later, Amna. Okay, now these are two junctions. Okay, this is relatively lower temperature and this is relatively higher temperature. Okay, now because of this, now we will keep one of this constant and known. One temperature should be known to us. For example, this. Okay, this temperature should be known and constant to us, and then this is measurable, is what we are measuring, right? Now this wire has better conductivity than this. Now because this wire has better conductivity, the electrons, basically in metals, we discussed the structure of metals in our previous classes. We know metals are made up of cations embedded in a sea of electrons, right? So the faster those electrons transmit their energies or, you know, move along, the better the conductivity, right? Now, because the conductivity of copper is better, copper will transmit the energy, or the electrons will flow faster in copper and reach this junction. Whereas in iron, because relatively the conductivity is slower, the electrons will take a little longer time compared to those of copper. So therefore, there is some difference in the electrons at this junction between these two, and even at this junction, because basically the conductivity is different of the two wires. So conductivity has to do with how fast the electrons can move from one end to the other, and either they will flow themselves or they will be transmitting energy. Now, because the conductivity is different, they are transmitting this energy, or the electrons are flowing at different rates. And so there is difference of electron energy, or even, you know, the number of electrons which can be transmitted. Okay, because of which there is difference in current. Difference in current meaning there is voltage difference. Voltage difference. Now, what is voltage? What is voltage? Voltage is basically difference in the energies of electrons. I will not go into the details because that will take me into electrical physics, and I want to stick to this topic for now. But for your understanding, for you to understand, voltage is the difference in the energies of electrons. Difference in the energies of electrons. I will not say anything more than that because you will get confused and then you will ask so many questions and we will deviate from the topic, and I don't want that. Your book is not explaining all of this. Your book is not explaining all of this. Your book has just simply mentioned that these two junctions are at different temperatures, and so they are at different voltages, and so that difference is measured by this voltmeter. And so this is how the change in temperature is represented by the voltage in this voltmeter. Okay, but I wanted to, you know, go into a little detail about how, how. So it has to do with the electron energies, and you know, because it is a better conductor, therefore easy transmission of energy through the electrons, and therefore more energetic electrons here, less energetic, relatively less energetic electrons here. So there is some difference. That difference is called voltage. There is some difference, and this difference is being measured by this voltmeter. Okay, and this difference is greater if the temperature, I mean, it is dependent upon the temperature. Okay, so that is how the voltmeter is representing the temperature. This is how thermocouples act. Okay, don't get confused. These thermometers that they have mentioned, they, especially this thermochromic, resistance, thermistor, they have a lot of electrical physics in them. Okay, you will be asking a lot of whys here. Okay, there are answers to those whys, but you will need, you will have to go into details to answer those whys. But the advantage of this thermocouple, what you should remember, basically what you should remember is that this thermocouple thermometer has a very wide range. So that is big point. That is a big plus point for this thermocouple thermometer. We can use them in industries where you have to measure temperatures above 1000 degrees Celsius. So thermocouples are good for that. Okay, especially rapidly changing temperatures, extremely, because it is dealing with current. It is dealing with current. So rapid detection of change in temperature, and therefore rapid response to changes in external temperatures. And also it is sensitive to small changes in temperature. Small objects will have small changes in temperature. Even those can be detected. So sensitivity is pretty high and the range is pretty good. Okay, so those are the plus points for this thermocouple thermometer. Okay, that's that about thermocouple. Okay, I know you guys must have a big list of questions for me. Okay, let me see. How many thermometers are there in total? I have no idea. I have no idea. What happens if there is a large bulb? A large bulb, I think, should give you greater sensitivity. It should give you greater sensitivity because more surface area exposed to the surrounding temperature. and therefore quicker result, quicker expansion. Yeah, okay. Please do not chat with each other. You will chat only with me, okay? Only with me. No chatting with each other, I'm telling you. We studied in grade 6 that milk bottles break due to hot liquid inside them, so don't the thermometers break? Yes, that's a very valid point, Amna. I think the glass that makes the thermometers are specialized glasses. They have to withstand the extreme temperatures. Otherwise, they wouldn't be making those thermometers with those glass. And the reason why milk bottles break is because of uneven distribution of energy. So some parts are hotter than the other, so they expand, and the parts which are less hot, they contract. And because of this expansion and contraction, there's crack and there's breaking. That does not happen in thermometers. I don't think so. This glass is special glass, and if it contracts or expands, it does it together. I mean, it does it all together. Okay. Yes, thermocouple is an instrument for measuring temperature. Yes, just like thermometer, but it uses voltage difference between two different metals, which is in turn due to their different conductivities. Yes, voltage can also be referred to as the electromotive force. What type of question can come about thermocouple thermometers? We will do past papers. We'll find out. Okay, we will find out. So basically you make one reading either at the hot or cold junction and subtract it by the reading on the voltmeter. No. You don't subtract or add anything. Okay, but just one junction should be at a known temperature, and it preferably should be lower than what you're trying to measure. The other junction should be in the substance, the temperature of which you want to measure. And then digital voltmeter will just give you the value. Okay, that is a digital instrument. It will convert that voltage into temperature. You don't have to add or subtract anything. Okay. Does the type of glass affect readings like Pyrex? I have no idea about that. I can't message privately to you. No, you talk to me, chat with me through this window. Okay. What do thermocouple wire colors indicate? Nothing. No, not. If you're talking about the colors used in the book, no, they're just there to indicate that they're two different metals. Okay. Now let's move on to resistance thermometers. Okay, resistance thermometers. As the name suggests, it uses the electrical resistance. Okay, it uses the electrical resistance, which in case of metals increases with temperature. Okay, now you might ask me that as we increase the temperature, aren't the electrons moving more vigorously, and therefore shouldn't that increase the conductivity? Well, yes, I was also confused by that. But then I learned that if you look at the structure of metals closely, and I'll show you that metal structure again. The one that I usually show you, I will show you again. You know, those cations embedded in a sea of electrons. Okay, let me see. Yeah, this one. This. Yeah, cations embedded in a sea of electrons. Now, when we are increasing the temperature, these cations also start vibrating real vigorously. These cations also start vibrating real vigorously, so much so that they hinder the movement of electrons. I mean, the flow of electrons from one end to the other. Okay. So the cations also start vibrating so vigorously, and because you know they are bigger in size, they are whole atoms, so they hinder. There is hindrance to the flow of electrons from a hotter region to a lower region, to a colder region, right? So therefore, the conductivity of metals decreases. Now these electrons were initially, these electrons were initially free, and they were flowing easily, because the cations were not moving. They were the only ones moving. So it was easier for them to flow from one end to the other. But when the cations also started vibrating, now they're coming in their way. And when they're coming in their way, the flow of electrons has now become difficult. And therefore, the conductivity of metals decreases with temperature, or in other words, you can say that the resistance increases of metals with increase in temperature. Okay, so a resistance is just the opposite of conductivity. So if conductivity is increasing, meaning resistance is decreasing. If conductivity is decreasing, that means resistance is increasing. So they are inversely proportional to each other. Okay. So why are we using platinum? Why are we using platinum for this purpose, for this resistance thermometer? We wanted some metal. We wanted some metal which would stay at room temperature. Which would stay solid at normal temperatures. I mean, even higher than normal temperatures. It should, you know, like for a very wide range, it should stay solid. Okay. And it should be unreactive. It should not be reacting with the atmospheric substances at higher temperatures. So platinum was the best choice. Okay. Another good quality for platinum is that it can be drawn into fine wires and it is still not too soft. Okay. Mercury would get too soft because it's liquid at room temperature. So mercury, no way. Okay. So platinum. Okay. So when its resistance will increase with temperature, what will happen? Using this, V is equal to IR. Remember this formula from your electrical physics? Yes, I will send all the notes in the group, don't you worry. But remember one thing, everybody, you are not required to know or learn all of this. Please do not learn, okay? Just understand the points I'm trying to make in front of you. That's it. I don't want you to be, you know, memorizing. I mean, it's okay to have a rough idea regarding the ranges of temperature, but don't go ahead and, you know, learn word to word. By the way, I am really against rectification and word to word learning. You know what, how you should study? The best way, explain to somebody. If you do not have somebody, you know what you should do? I used to do that when I was a student, and it's helping me now. I would lock myself up in a room. I mean, not lock, but I would be in a room alone where nobody would disturb me. And I would imagine students around me and I would explain them because I love explaining. I love explaining since my childhood. And I've been doing this since I was in grade 5. Since I was in grade 5, I used to do that. I used to explain to my imaginary students, if you have somebody to teach, well and good. If you don't have anybody to teach, it's okay. You can imagine your friends. You know what? Imagining your students and teaching them is the best way of learning. Trust me, because you can go on making mistakes. Nobody's there to look at you. You can keep on making mistakes, and you can, whatever questions are coming into your mind, try to get the answers yourself first by reading as many books. And in today's day, you have Google. We wouldn't have Google. So all I would have was, you know, books I would issue from the libraries, and then I would go after my teachers. And so whatever I could gather, I would have to do with that. Okay. So please do not learn, explain. Okay. I don't want to confuse you. I don't want to confuse you. I don't want people to say that, you know, she's going ahead of IGCSE level. I don't want to do that. This is only so that you understand, and you do not have to memorize blindly. I don't like memorization, blind memorization. I don't like it. Okay. So please don't memorize these notes. Okay. So, okay, as the resistance will increase, then the temperature, as the temperature will increase, the resistance will increase. And as the resistance will increase, what will increase according to this formula? The voltage would increase. Voltage would increase. So that means resistance and voltage are directly proportional. So this voltage will be again read by a voltmeter and it will be translated meaning, you know, converted into the corresponding temperature. Now don't ask me how is it translated. Okay, you don't have to deal with that. Okay, that's not included for you. Okay, so this is resistance thermometer. Okay, advantages and disadvantages for resistance thermometer. Resistance thermometer, it has a wide range of temperature from -200 till 1200 degrees Celsius. Well, by the way, you should have a rough idea of this. Okay, now the things that I tell you that make mnemonics of, that you should know this, those things, yes, you can rectify. Okay, but I will tell you a better way of learning even those points. To ask somebody to ask you, or you can ask yourself daily, every day, daily, you ask yourself at least once a day, at least once a day. After 1 or 2 weeks, on your fingertips, on your, that thing will be on your fingertips. Okay, so accurate for a wide range, for this to this, used for measuring large temperature, and as you can see, the range from very low to very high, -200 to 1200. Therefore, resistance thermometers are very good for industries. Okay, they're very good for measuring temperature for industries. Now, disadvantage is that this resistance thermometer is very bulky, suitable for steady temperatures. Why? Why bulky? Now this, your book is not mentioning why bulky. The book has only said bulky. Now why? I don't want you to memorize, so I'm telling you. Now, the resistance of platinum is very low. Okay, it is very low. So if we want the changes in resistance to be measurable, to be enough for us to be able to measure them, the length of platinum should be big, because bigger the length, higher the resistance. Bigger the length, higher the resistance. Okay, so therefore, when we use large lengths of platinum, that will make the whole apparatus bulky because of the long length of platinum. Because of long length of platinum. Why? Because we want enough resistance to be able to measure, and the resistance of platinum is a little low. For minor changes in temperature, the resistance change would not be enough for us to be able to measure it. Therefore, we will use long length of platinum. Long length of platinum will give us resistance. By the way, we have not studied the factors affecting resistance. Okay, resistance is directly proportional to length. So as the length increases, the resistance increases. So knowing this is enough. As you increase the length, the resistance increases. Okay, so it is enough for us to measure. Okay, it is suitable for steady temperatures. Again, steady temperatures meaning temperatures which stay constant. I mean, rapidly changing temperatures, because you know we are using such a long strip of platinum, it won't be able to respond too well to rapidly changing temperatures. It needs some time, because it's a big length. It needs some time for contraction and expansion. Therefore, it is suitable for steady temperatures rather than rapidly changing temperatures. Okay, this resistance thermometer. Now, come to thermistor. Thermistor is a combination of thermal and resistor. So thermistor. Now, it is just the opposite of resistance thermometer. Again, we are measuring resistance. The physical property we're making use of, which is changing with temperature, is resistance. Okay, but here, as the temperature is increasing, resistance is decreasing. As the temperature is increasing, resistance is decreasing. Now you will ask me why, right? So that's a big explanation. I think 1 hour is over. I will continue this in the next class. I will take your questions. I know this was a new topic. You guys must be confused. Are thermometers made up of Pyrex? No idea. I don't know. Resistance thermometers didn't get it. Now, see, you are explaining to real students. Yes, I'm now explaining to real students. Least reactive, check here. Do you have any picture of resistance thermometers? Let me see. Haven't they given here? Let me see if I get, if I have. No, maybe I don't remember. I don't remember having. Okay, let me. No, I don't have. I don't have. Sorry about that. You guys have gotten used to seeing pictures, haven't you? You want pictures for everything. Miss, let's do questions. You want to do questions? Where thermocouples are used? Thermocouples are used in industries. I told you, Nabil. I should Google. I should Google what? Okay. Okay, now I'm out of time. Okay. Okay, but because you requested, I'm sharing. Let me. But it's not that. I don't think you'll be excited to see it. Resistance thermometer. Let's see. Yeah. This is what I got. Wait. This is what I got. Yeah, resistance thermometer with platinum. Am I sharing my screen? Oh, sorry. Okay. This is what I got. Wait. Here. This is, and this has platinum inside. This this is platinum inside. Okay, Ibrahim, are you happy now? Did you guys read this chapter? Did you guys, who read the chapter? Who read this chapter before attending this class? Who read this chapter before attending this class? See, if you will read, I'm telling you, things will be easier for you. No, the reason, because you know, because you see, when your brain is receiving information for the first time, it doesn't go inside immediately. But when you have already read something and then you listen to your teacher or the explanation, and when the information is entering your brain for the second time, then it settles better. Okay, you did a little. You know what? You guys should be studying. You have to take exam, and I'm the one studying. You know, before the class, I'm the one preparing and you know, making all these notes. Okay, so where is the resistor placed in resistance thermometer? Resistor in the resistance thermometer. Beta, I cannot explain you the structure of that. Okay, that is not included. Okay, you don't have to go into the details of that structure. The platinum is the resistor, you know, the platinum. Now I don't know which one of these tubes is platinum. It is the platinum, the resistance of which will represent the temperature. Okay, the platinum wire. Okay. Okay, then in the next class, we will start with thermistor. Okay, so for now, I am, do you have any questions? Resistance thermometers contain resistors. Yes, yes. Which class is tomorrow? I think we should continue this. We should continue this. We should end this chapter. And then inshallah, we will also do questions. Okay, we will do the end of chapter questions as well as a few past paper questions. Its resistance against what? Resistance to, what was it? To electricity. Yeah, the electric current. Resistance to electric current. Okay, in response to increase in temperature. Your question, Sayyid Nabil. Timing will be same, inshallah. If I will usually stay between 8 and 9. Okay, if there is any change, because sometimes, you know, this meeting room is required for other activities, then I need to change the timings accordingly. Jazakallahu khairan, Ibrahim, for your compliment. Jazakallahu khairan. Okay, okay. Is that it? You guys ask such difficult questions. Oh my God. And by the way, Amna, that question that you asked me about complete and incomplete combustion, I sort of got the answer to that question. Inshallah, we will discuss in chemistry class. Jazakallahu khairan, Usman Aslam. Jazakallahu khairan. Okay. Okay, now I'm ending the meeting. Jazakallahu khairan. I know you guys you guys are encouraging me a lot. It is difficult to take time out every day, but because of your encouragement, I manage to do all of this. Jazakallahu khairan, Nabil. Okay, okay. I'm unmuting all of you.
My question.
Sorry, Lafis miss. Oh. Oh.